Okay, so this is going to be practice problem 3, and it says the nursing student at TCTC uses a pair of 4-inch long tweezers to remove a wooden sliver from an engineering teacher's hand. The student is applying 1 pound of squeezing force to the tweezers. If more than a fifth a pound of force is applied to the sliver, it will break and become difficult to remove. Sketch and label the system. Alright, so I drew some little tweezers here. Alright, and let's think about what tweezers really are. Okay, they're a simple machine that has the fulcrum at the very end here. Alright, and then we apply a force. Let me see if I won't rotate that really around. I'll turn it like this. Okay, so what we really do is we squeeze here, right, on the tweezers, and then they squeeze there. Okay, so let's think about this piece is the fulcrum, right, and this is where I'm going to squeeze. So what do? Do I do the effort or the resistance? I apply the effort force, right? So let's label that the effort force, and look in our problem. It says the student, okay, so she's applying the effort force in this case, applies 1 pound of force. All right, and so a fifth of a pound of force is applied to the sliver. All right, so that means that's where the load is applied, and it is 1/5 of a pound. All right, and it says if more than that's applied, it will become difficult to remove. All right, so when we think about this, we're supposed to sketch and label the system. So I've got the effort force and the resistance force, and I need to do the effort distance and the resistance distance. So here's the effort distance. I don't really know it. Okay, and here's the resistance distance. Okay, and when I look back at my problem, I don't see any other numbers, but guys, remember to read the words. It says a nursing student at Tri-County uses a pair of 4-inch long tweezers. All right, so the whole tweezers are 4 inches long. Okay, guys, that means the resistance distance is the entire length of the tweezers, which is 4 inches. All right, and I don't know this effort distance. Okay, so now I've sketched and labeled the system, and this is a good labeling, pretty good little sketch. Sorry, I made it on the computer so I could record it for you pretty easily. All right, and then I want to know what's the actual mechanical advantage of the system. Okay, the actual mechanical advantage is the resistance force divided by the effort force. So remember, that's going to work out to be, the AMA is going to be equal to 1 divided by 5 pounds. That thing, right, divided by 1 pound, which means the AMA is going to be what? It's going to be 1 divided by 5, it's going to be 0.2, I think. I really need to get my calculator out, don't I? Alright, and the pounds cancel. Let me grab my calculator. I'm pretty confident of that, but I don't want to have a mistake. Great. Okay, that is 0.2, so, and the pounds cancel. Sorry for the delay there. Alright, so now we know the AMA. And it says, how far from the fulcrum of the tweezers must they be held to avoid damaging the sliver? So how far is this where my fingers go? Alright, and I'm going to use this formula. that we have FE times DE equals FR times DR. Alright, slide this up here. Alright, so let's look at that. So that's going to be FE is 1 pound, and I don't know DE is going to be equal to 0.2 pounds times 4 inches. Sorry, I left my pounds off over there. Okay, so to solve this, I got to divide both sides by 1 pound, and I'm going to get DE is equal to 0.2 times 4 should be 0.8, so I'll have 0.8 pound inches. That little dash just means the units are multiplied, divided by 1 pound. And now the pounds are going to cancel, and I'm going to have, that's going to be equal to 0.8 inches. Alright, and that's the answer to that problem. I hope this helps.